Hello class. Today I'll be talking to you guys about the quiz review that's going to happen tomorrow. Tomorrow I'll be posting no videos. It will be just strictly just the assessment. You'll be submitting it on paper online, and then that's going to be it. No homework over the weekend, of course. Uh, you'll be just tested on graphing the trigonometric functions only involving amplitude. Starting next week, we're going to be talking about the vertical shift, and hopefully if we can get to phase shift, that would be wonderful. So those two will be dealing with the graph transformations and how we can incorporate that into a trigonometric function graph. All this is based upon graph transformations in algebra 2. So because we haven't really talked about graph transformations in detail, but no worries, it's pretty much the same as what we're going to be dealing with in terms of vertical shift, phase shift, and that kind of stuff. Okay, so let's go over the basics. Remember, guys, when I ask you what the amplitude is in a given graph, you will have to look at the midline and then tell me the distance from the midline to the highest point or from the midline to the lowest point. So for example, instead of me giving you, let's say, 3 cosine of x, you guys automatically know that the amplitude is 3. But if I were to give you something like, let's say, something like this, where it's a sine graph, where I tell you that this is at a positive 4 and this is at negative 4, this is the midline from the center. Because we haven't talked about really vertical shifts yet, it's not going to be that difficult, but it's measure of from the center to the highest point, which would be 4, or from the midpoint, midline to the lowest point, which is at negative 4, so but that distance is still 4. So you will always tell me that it's going to be amplitude of 4. Remember, the values that it follows are these main points that's going to circle over and over and over again. So that's why if you were to put this unit circle in a on a straight xy coordinate plane, you make a cycle of up and downs because you go from 1, 0, negative 1, 0 for your cosine, 0, 1, 0, negative 1, 0, and it's going to go on and on and on in this counterclockwise fashion. All the x values are your cosine of the angle, and all your y values is sine of the angle. We have already established that. Okay. Okay. Now let's go over some basics here. Remember, I'm gonna give you a table, and if I were to ask you to fill that in, you have to be able to fill that in. And I modified the table just a little bit to be a little bit accommodating to the things we're going to be doing. So remember, if you follow a unit circle chart, we notice that the 0 will always start from 0 for sine of x. And when you go to pi over 2, going into the counterclockwise direction, it becomes a 1. And if it goes in the clockwise direction, it will be a negative 1. And then the cycle will repeat. Max, mid, minimum, mid, and then it will go 1, 0, negative 1, 0, that pattern. This will go from negative 1 to 0 to positive 1 to 0. So if I were to plot that, 0, 0, pi over 2 will be 1, 0, negative 1, 0. And then by having with these, what we call these 5 essential points, you can already see this one full length of wave, one uphill and one downhill, that's what I like to call it. Negative 1, 0, positive 1, 0. On the other end, you will also be able to see the same thing. So that's regular sine of x. And this is a review selection section for you again. Cosine, 0 starts at 1. That's the main idea. And then the cycle repeats itself over and over again. This becomes 0, negative 1, 0, and then positive 1 once again. And on the other end, it will be 0, negative 1, 0, positive 1. So in a way, it's very symmetrical. So it's going to start at 0, 1, 0, negative 1, 0, and positive 1. Now notice that these 5 essential points on the cosine, I know that it doesn't look like a one wave as we have been able to see on the sine graph, but this is one downhill and this is half of uphill, half of uphill, so it will still be considered a one full length of wave. A one full length of wave should have one uphill and one downhill, and that's going to be the right hand side, 0, negative 1, 0, and then positive 1. We get this one full length wave right here as well. So that would be your cosine. You don't have to shade it in like the way I did it. That's not necessary. I just did that to indicate the full wave that contains one uphill, one downhill. All right, next slide. So now let's graph the following, which is 4 sine of x. Now for these questions, when I ask you to fill out the table, you might want to go back to your original for those of you that are still struggling. Notice that these values that are at zeros, even if you were to multiply it by 4, it doesn't make any difference. So if I go back to this chart, I know that regular sine of x starts at 0, and all the other values, if I were to repeat, 0, 1, 0, negative 1, 0, negative 1, 0, 1, 0, these values will simply get multiplied by 4 for all of these guys. That's what's really happening. So if I were to do that, all of these values that you see, 0 times 4, what's going to happen to them? They're all going to be zeros. So why bother even thinking about them, right? So I'm going to go to my graph, and for those values specifically, 0, pi, 2 pi, negative pi, and negative 2 pi, these values will always be at zeros if we're just talking about the amplitude. Okay? Now these values get extended by 4s. So that will be a positive 4, negative 4, negative 4, and positive 4. So starting at pi over 2, it's going to go up all the way at positive 4. It's going to go all the way down to negative 4 at 3 pi over 2. Going to go all the way down to negative 4 at pi over 2. Going to go all the way up. So the wave will look like this. Notice the amplitude from the midline to the highest point is 4. So that's how you can see that. But when you're plotting these by using the table chart above, make sure you have what we call these essential points plotted, and then please connect the dots and draw it for me. So that will be a 4 sine of x. The second example that you see here is a negative 3 cosine of x. Now I'm going to write down the original values again. 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. Again, if I were to plot the times 4 to every single one of these guys, you will see that some of these, oh, I'm sorry, that's not times 4. My apologies there. It will be times negative 3. So times negative 3 on each and every single one. That's not x minus 3, that's times negative 3. Please know that. Times negative 3 times negative 3. All of these values that has zeros, they will still remain as zeros. So those are pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So they'll all be staying at 0. Now the other values that's going to change, okay, are these guys right here. So those guys are going to be at negative 3, positive 3, negative 3, positive 3, and negative 3. So let's take a look at starting at 0, comma, negative 3. So I'm going to go to 0, and then what's going to happen is, remember it started at 0, comma 1 originally? Well, that's not going to happen in this case because it multiplied by negative, and you remember yesterday we talked about how that reflects across x-axis. So it goes from the bottom. So you go all the way down that negative 3. Okay? And then you go to positive 3 for pi, negative 3 for 2 pi, 3 for negative pi, negative 3 for negative 2 pi. So your graph will look like that. Now, please, when you graph this, don't do this, okay? You know that it's not going to be like a letter M shape. And some of you guys are still really having trouble with just like sketching it. Just make sure you have like some sort of a parabola shape at the top and parabola shape at the bottom. I know that we're not all fantastic artists, but all children are born artists. We have all talked about that. And I know that you guys can draw parabolic shapes. Plot the correct points. That's really what I'm really looking into. And sketching it, I'll give you some sort of a leniency with that. But make sure it looks good. Bottom line. Since we talked about a negative sign, I also want to talk to you guys about a negative version of the fraction. We really didn't talk about this yesterday, but again, some of you guys might saying like, "Oh my God, Mr. Kim, please don't do that. It's kind of redundant at this point." But I know it'll help you, some of you guys, to write down the original portion and then apply the amplitude, which is multiplying by negative 1 over 4. Okay, again, the zeros stays consistent. 0 here, 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 there, and there. Now, negative pi over 2, it's going to become negative 1 times negative 1 over 4. So that's positive 1 over 4, negative 1 over 4, negative 1 over 4, and then positive 1 over 4. So what that means is this guy, it shrinks it, because instead of doubling it or multiplying by 4 like before, we are going to take the amplitude and make sure that it's very, very small, which is 1 over 4. So if that is 1, 1 over 4 is actually a quarter of that. It's very, very tiny. So starting at pi over 2, which is going to be at negative 1 over 4, because you remember we reflected also by multiplying by negative, we reflected across x-axis. So it's going to start from negative 1 over 4, reach positive 1 over 4, reach positive 1 over 4 here, and then reach negative 1 over 4 here. So it's going to be very, 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 very small graph. Now, I know that it's kind of approximated, but you could also indicate that's negative 1 over 4, positive 1 over 4 if you want to really indicate that, just so that I know. The whole reason why I'm giving you the table and then making a graph out of it is for me to see the numerical values intact. For the last question, the last slide here, take a look at the question here, and then please try to draw this on your own. Pause the video and then let me know when you have it. Okay, so I'm going to take a look at these values because I know that they're all going to be zeros. I'm skipping a lot of steps here. And I know that this is going to be starting at 3 over 4, and notice that we're multiplying by positive 3 over 4. Then it's going to be negative 3 over 4, positive 3 over 4, negative 3 over 4, and positive 3 over 4. Okay? And then I'm going to plot the zeros. At 0, it's going to be 3 over 4. That's about 0.75, so I'm going to put the point a little bit closer to the 1 than at 0. Then at 0. Then at negative 3 over 4, positive 3. Oh, I'm sorry, that's not the way. This is going to be at negative 3 over 4, and then again, positive 3 over 4. Negative 3 over 4, then positive 3 over 4. So my graph look like that. Okay? So if that's really not, that's really close to being negative 1, just indicate where this value is at negative 3 over 4, indicate where this value is at 3 over 4, and I'll give you the benefit of the doubt and say that, okay, you made sure that it's going to be a little bit less than 1, or negative 1. I mean, a little bit greater than negative 1, a little bit less than positive 1. Okay. All right. So hope this video helped. I'm going to give you 4 more questions to do like this on a separate sheet of paper. Just finish that for today. That will be your review. And then you will get 4 questions like that again for tomorrow for your quiz. No video tomorrow. Make sure you stay safe out there, and I'll see you guys next week. Thank you. Have a good day.